go over some Regents questions on atomic structure. This first one here, number 17, it says which particle has a negative charge and has a mass that's approximately 1 over 1836 times the mass of a proton. But if we forget and we went to table O, the beta particle is an electron, and you see it's the one that has the bottom number is the mass. The bottom number is the charge. It has a charge of -1. So it has to be an electron. And here the mass of an electron is approximately 1 over 1836 times the mass of a proton. That's just the definition you have to know. What's the mass of an electron? 1 over 1836 times the mass of a proton. Which describes an electron? It obviously has a smaller mass than a proton and a negative charge, which we already looked up on table O. Which particle has a mass of 1 and a positive charge? So mass is the top number and a positive charge. Well, if we went to table O and look it up, who has a mass of 1 and a charge of 1? It looks like it's a proton. So you don't have to memorize these. Which is neutral? Well, that means the charge is 0. So if we went to table O and we looked up a neutron, neutron has a bottom number of a charge 0. So the answer there is a neutron has a 0 charge. Who has the same mass? Which particle has the same mass as a proton? Well, let's look. Proton is a 1. Neutron is a 1. So there's your answer, neutron and proton. Which two particles have the same mass? Proton, neutron. Very popular Regents question. Which two particles have the same mass? I told you we went to table O and I already showed you that neutron was this, proton was this, and we know the top number is the mass. So it's proton and neutron. And notice this says positrons to trick us. And if we went to table O, a positron is a mass of 0 and a charge of +1. So you have to make sure you read carefully. What are the nucleons? Nucleons is what's inside the nucleus, and inside the nucleus are protons and neutrons, and electrons are outside in orbitals. How many protons are in the nucleus of beryllium? Well, we're going to look up beryllium on the periodic table. Beryllium is Be, and it has an atomic number of 4. So it has 4 protons. That charge there is not the nuclear charge. That 2 there is not the nuclear charge, so the answer is 4. Okay. Next set of questions. Atoms of a sample of an element. Atoms in a sample of an element must contain nuclei with the same number of protons, and we know that if you're an atom, the protons never change. It identifies the element. What's the atomic number always equal to? Protons. That definition you have to know. Now, 2 atoms will always have the same atomic number if they have the same number of protons, because protons means atomic number. So you have to know all atoms have the same atomic number, same number of protons. If you have the same atomic number, it's the same element. So which substance is composed of atoms that have the same atomic number? We're looking for an element. And if you went to table S, all these words, they're not found on table S. Magnesium is, because that's your element Mg. And again, all the atoms of argon have the same atomic number. They want you to know that concept. Now, if the number of neutrons increases, what happens to the nuclear charge? Well, who's inside the nucleus? Protons and neutrons. Neutrons have no charge. So if the neutrons change, it's not going to affect the nuclear charge. The nuclear charge will remain the same because the nuclear charge means protons. Now, which atom has the greatest nuclear charge? Well, we have to look up argon, and it's already on there, but I'm going to show you argon right here has an atomic number of 18. So that one has a nuclear charge of 18. Aluminum, if we go to the periodic table, Aluminum has an atomic number of 13. And then we have silicon. Silicon, I wrote over it here. Silicon has an atomic number of 14, and that's what the nuclear charge is. And then sodium, Na, is right over here. That's atomic number 11. So they're all written in already for us. But who has the greatest? So we want the largest number, and the answer is argon. This one, who has the greatest nuclear charge, we know that means protons. This one has a 6, 1, 2, and 7. So the greatest would be 7. What's the nuclear charge of an atom with a mass of 23 and an atomic number of 11? Nuclear charge is the protons, which is the atomic number, so the answer is 11. Now, when you form an ion, ions gain or lose electrons. So if it's +1, it means it lost an electron. The protons of an atom never change, remains the same. So a sodium atom and a sodium ion must have the same number of protons because protons never change. They identify an element. I'm going to do some more questions now. What's the number of protons here? We know it's the atomic number, which is that bottom number, so the answer is 27. Now, we have to know if you're a neutral atom. I say ape. If you're an atom, the P equals the E. The protons equal the electrons. So if you have 8 protons, you can have 8 electrons. An ion with 5 protons, 6 neutrons, and a charge of +3. What's the atomic number? Well, that never changes. That's the number of protons. So the answer is going to be 5. Now, you see here we have 6 protons and 6 electrons. That means it's neutral. And so we know it's neutral. And now we have to decide, is it carbon or nitrogen? Well, protons never change. So if we go to the periodic table, which element has 6 protons, and it looks like it's carbon. So it's a neutral carbon atom. Now, mass number is protons plus neutrons. So if you have 20 protons and 22 neutrons, the total mass is 42, and protons is the bottom number. Now, which atom is this? Well, the atomic number identifies the element, so we have to look up atomic number 11 here, and it's sodium right over here. So the answer is sodium. They don't ask this question anymore, but you never know. The atomic mass is 1/12 the mass of carbon-12. That's the definition. This is old material. I don't see it on the new Regents, but some of the schools still ask this. That's why I just want to go over it. Atomic mass is based on carbon-12. Now I'm going to go over some of the electron config. It says a gold atom, so I'm going to go to the periodic table and I'm going to look up gold. Gold is AU. No, we can't do that one. Okay, I'm going to go over some electron config problems. This one says a calcium ion. So we're going to look up calcium. Calcium is right over here, 2882. So I'm going to write that out. That's ground state, 2882. But the +2 means it lost 2, so it's just 288. Next one says chloride ion. I'm going to look up chlorine first. Chlorine is right over here, 287. So if it was ground state, it would be 287, but the minus there means it gained 1, so it becomes 288. Same thing here, it says oxygen ion, so I'm going to look up oxygen. Oxygen is 26. So instead of 26, it gained 2, so it becomes 28, and there it is. Now here it says potassium ion in the ground state, but they didn't give it to us. But if we go to periodic table, here's potassium. It has a +1, and it says 2881. So first I'm going to write the ground state, which is 2881, but then it lost one, so it's 288. Now I'm going to go over an electron configuration of an atom in the excited state. Well, excited state means it skips, so because it's an atom, the protons equal the electrons, so I could actually first count up the total electrons, and then I'm going to go to atomic number 3. And if we went to atomic number 3, this one says 2, 1, so that's regular ground. And then here, this one is atomic number 11, so I'm going to go to atomic number 11, which is right over here, which says 281, so that's ground, so that's not excited. And the next one says 282, which is atomic number 12, and if I go to atomic number 12, it says 282 over here, so that one is not excited state, that's ground, that's where you just look up. But if we look up atomic number 5, 5 is supposed to be 2, 3. Right over here, 2, 3. So boron is supposed to be 2, 3, but instead 2, 3 became a 2 and then skipped 1. The electrons went up. So now here they're specific about calcium atom in the excited state. So here I have to specifically look up calcium, which is calcium is 2882. Now, so instead 2882, that's ground, so I'm going to cross that one out. Maybe this becomes a 7, that becomes a 3, and that's it right there. That's not calcium, and that one's not calcium. Now here, this is just a bad copy, but how many protons in the nucleus of a silicon atom? It says atom. It says atom, so I'm going to look up silicon, and it says 14, because the atomic number never changes, so it's 14. Now it wants silicon in the ground state, so that you literally just copy 284 right over here. So it says 284, and then it wants the electron dot. Well, the last number tells you how many dots, so I need 4 dots. Now when it becomes -4, it means it gained 4 electrons. So if we took 284 and then we gain 4, it becomes 288, and they want to know which noble gas is 288. So we could go to the periodic table, and argon is the noble gas. That's 288. How many protons in a potassium atom? Protons never change. Let's look up potassium. Potassium here is 19 protons. Write the electron config in the ground state. Ground state just means we're going to look it up, so we're going to go back there, and it's 2881 if you look right here, so we're going to write 2881. And then what's the Lewis dot for an atom of potassium? Well, it's always the last number, and there's just a 1 there. Now, what happens when it becomes +1? It meant it lost 1 electron, so the new electron config is going to be 288, and we saw up here 288 was argon, so I'm just going to repeat the argon. I'm just going to repeat the argon.